talk about balancing budgets in maybe a slightly different way than we've all been hit with over the last month or two. And I'll touch on how our measurement skill has really improved and what that means as scientists. And then I'll try and bring this back to there's more going on with glaciers than just melt. And so you'll understand that by the end. And then I'll talk about our ability to forecast. And I think through the last week when I was putting this together, I maybe made a realization about forecasting that I think you'll enjoy. So the first thing to realize is where is the glacier ice on planet Earth? And not everyone is a glaciologist, and sometimes I forget that, and so I just throw this slide up at the beginning to show where the ice really is. And this is a view of the planet from below and above, and we see that both of the poles are covered in ice. The northern pole is covered with sea ice. I'm not going to talk about sea ice today, but you can see the Greenland ice sheet and the Antarctic ice sheet. That's where most of the glacier ice is on Earth. About roughly 90% of it is stored in Antarctica, 10% in Antarctica. That doesn't leave much for the glaciers. So why are we focused on the glaciers at all? And part of what I want to do today is convince you that even though the glaciers are small compared to the ice sheets, they are relevant, and we should be putting some focus on them. And on the right-hand side is the potential for sea level rise from each of these ice masses. So, and when I talk about the glaciers, I'm talking about all the aggregate sum of everything that's not included in the ice sheet. So if I say the small glaciers, the mountain glaciers, or just the glaciers, I'm talking about everything lumped together. So you can imagine that that's sort of a formidable task, and I'll show that, to lump it all together and study it. But we do need to get a handle on it. And it's not much of a sea level potential, especially when you have staggering numbers like 55, 60 meters locked up in Antarctica. So we've got a third of a meter, a foot in the glaciers. Who cares, right? So who does care? So that's one of the things I want to talk about today. Should we care, or should we move on? So here's a satellite image of Alaska, and from this sensor, the glaciers are sort of this light blue cyan color. And there's a lot of emphasis on the Arctic lately, and what you see from this picture is that Alaska's glaciers really aren't in the Arctic. And so by just funneling money towards the Arctic, we're kind of missing the boat in Alaska. Our glaciers are here along the coast, and they drain into the Gulf of Alaska. We've got about 90,000 square kilometers of surface area in Alaska, and that's another term like the glaciers. When I say Alaska, I also am including our neighbors in Canada. So, and both Anthony and Matt have worked on this problem too. So we've got about 13% of the world's mountain glaciers and ice caps. And mountain glaciers represent less than 1% of the volume, about 3% of the surface areal expression of the glacier ice on Earth. Alaska is home to the largest non-ice sheet contribution to global sea level rise. So another way to rephrase that is that we're home to the fastest changing glaciers on Earth. Their volume is changing faster than anywhere else on the planet. And their position right along the coast means that that water is going directly into the sea. So this is an important process that's happening right now. And we have a disproportionate role in sea level rise, as I'll show you next.